But I hope that this visual would make sense to you. So everybody pick up your little box or someone on your desk. Okay, so if we have this open box and I say, okay, from the full box from one side to the other is 21. Now we want it an open box, so fold up X, fold up X. Do you see how now we're getting there? So if the full amount 21, now we're folding up an X. Is there that X anymore? No. So we're taking 21 and now we're subtracting an X. That's only one side. Now fold up the other side. Are we subtracting off another X? Yep. So minus X again. So the length or the width, whatever you want to call it, is 21 minus 2 X's. Now think about it. If this is laying down and that full amount is 28, we're now taking up the side and the side. We're subtracting off 2 X's off that length, right? Yep. Does everybody see how this, I did it to try to help make sense? Okay, so that's 28 minus 2X. Does everybody see why those are the dimensions? Yeah. We did not see it on the homework. So then what's my height, guys? Look at your box. X. So here's my length, my width, or whatever, and then my height is X. So it says write a statement for volume. Length times width times height. So volume is 21 minus 2X times 28 minus 2X times X. That's all I said. I didn't say you had to write it in standard form. You didn't need to distribute it out. However, if you did, I wouldn't mark it out. Questions? Okay. Okay. So let's get to it, guys. You're going to want to have somewhere to take maybe some notes today. We've got to get right to it. Today is like one of my favorite lessons of all time. But each problem is time consuming. So I'm going to give you a second to get out a sheet of paper or a couple, because each problem is going to take up some room, and notice there's not a whole lot of room on the back side. Okay, so remember how we spent a whole day reviewing how to correctly solve a quadratic? Well, that's because that's just a teeny tiny piece of what we'll be doing today in all of our problems. So guys, factoring by grouping, when do we factor by grouping? Now remember, our goal is to factor something down to its linear factors, because then we can set linear factors equal to 0 and solve. Okay, so if you have no greatest common factor and it's not quadratic, and if you have 4 terms, look at this example, problem number 4 on the worksheet. There's 1, 2, 3, 4 terms. Does everybody see that? Not quadratic, it is not, does not have a greatest common factor, and there's 4 terms. You're going to try factoring by grouping. So what you do is group the first 2 terms. You group the second 2 terms, including the sign, and then you'll factor out the greatest common factor out of each group. So what's in common, the greatest thing in common in 40b cubed minus 25b squared? 5b squared. Correct. Now we'll go back, divide each by 5b squared, divide by 5b squared. 40 divided by 5 is 8, right? V cubed divided by v squared is v. Negative 25 divided by 5 is negative 5. V squared over v squared is 1. Then we'll factor this group. And if there's a negative in front, we factor out a negative. So won't we factor out negative 2? Factor out a negative 2. Divide each term by negative 2. So left in this first term, negative 16 divided by negative 2 is positive 8. V. Positive 10 divided by negative 2 is negative 5. Check your safe haven. If it truly factors by grouping, your safe haven will be the same. Do you see how this is like a quadratic now? Similar. Okay, now look. A lot of you still do not understand what we're doing here, so pay attention. You're doing weird things. We have 2 terms. Listen, don't just look at the process. We have 1, 2 terms. Terms are separated by plus or minus signs. What is in common? 8b minus 5. So we're going to factor out 8b minus 5. A lot of people have been writing 8b minus 5 squared. No, it's just 8b minus 5. We factored it out. So then go back and divide each term by 8b minus 5. So left in the first term is 5b squared. Left in the second term, minus 2. Now I want you to look. Don't we have, sorry, I want to change colors. That is the worst color. Don't we have a linear factor, degree 1? And then we look right here, we say, oh, this is a quadratic. Okay, we better check to see if this factors further. So we're doing what multiplies to be a times c, which is negative 10. 5a squared. 5 is sorry, that was weird. I said that word. Quadratics have the form ax squared plus bx plus c. So a and c, correct? So we're looking for what multiplies to be negative 10 and adds up to be 0, nothing. So that doesn't factor any further. So if I said factor, we'd be done, correct? Okay, sweet. So does everybody understand how to factor that? Now I'm going to take one step further. I'm not going to say factor, I'm going to say solve. So we would solve by factoring. So now can't we just set each of those equal to 0 and solve? Okay, so we have 8b minus 5 is equal to 0. 8b minus 5 equals 0. We also have 5b squared minus 2 equals 0. Let's solve for x in each case, solve for v in each case. When we add 5, so we have 8b is equal to 5, divide by 8, divide by 8. So v is equal to 5 over 8. There's one of our solutions. Now looking over here, it's quadratic. It didn't factor, so we can't solve it by factoring. And we wouldn't anyway. Wouldn't we solve by taking square roots? Missing middle values. We'd add 2. So we have 5b squared is equal to 2. Then we would first divide by 5. So we have b squared is equal to 2/5. Now we square root both sides of the equation. Root cancels out with power. B is equal to, we can't forget, plus and minus. If that doesn't simplify, 2 over 5, and it doesn't, we split it up. The square root of 2 over the square root of 5. Is that answer appropriate? No, because we what? We can't have a radical in the bottom of a fraction, so we've got to rationalize the denominator, right? So that is our answer. We just got to write the appropriate answer. So we just multiply by the square root of 5 over the square root of 5. Multiply straight across. So 2 times 5 is 10. We have plus and minus the square root of 10 all over the square root of 25, right? Which is 5. Now can I divide underneath the square root with something that's not? No. So don't we have 3 solutions? 1, 2, 3. Yep. Now look back up at your original problem. Sorry. If I can scroll back up there. Wasn't it degree 3 the highest degree? Yeah. Then you should have 3 solutions. Questions? Okay. Sweet. Okay, do the front of the worksheet. And this is just to prepare you for what we're doing today. So I'm only going to give you a couple minutes. But I want you to solve them. Even though it just says factor, I want you to solve. Today we're solving, not just factoring. We're going to learn the good, like what we're actually learning. This is all review from secondary math 2, the front. Yes. Up here, pinky promise, okay? So now we're going to talk about how to solve something that's quadratic in form. I would pull myself away. This is completely new to you, okay? So this is one you'll use. If I said you solve, you always say, okay, can I solve by factoring, right? So anyways, solving quadratic in form, this is when you will use this method. If you have 3 terms, or 2 sometimes, if you have 3 terms and it's not quadratic, but looks quadratic in form, meaning, so then we will use substitution and solve it as a quadratic, and then we'll go back and find the solutions. So everybody look up here. Do you see how this is x to the 4th minus x squared minus 2? Yeah. That is not quadratic. As it is right now, we would not do h and c adds up to be b because it's not quadratic. That's a quadratic method. However, there is 3 terms. And if I told you, well, x to the 4th, isn't that just x squared squared? Yeah. Right? Raise the power to a power and you multiply. So really we have x squared squared minus x squared minus 2. So if I made a u substitution and I say let x squared equal u, then we'll replace our x squared with a u. So won't this piece become u, which is u squared, minus, we're replacing x squared with a u, so minus u minus 2. Now looking at that, we know how to solve that. We're going to try solving the quadratic by factoring, right? That's the easiest way. Wouldn't it be quick factoring if it did factor? And if we could not solve it by factoring, then quadratic formula. However, if they're quadratic in form, there's a good chance they'll factor, but not always. Does everybody see how I made a u substitution? So So then once we solve for u, that won't be our solution, but we'll use u. We'll go back and say, well, we knew u equals x squared, so we'll plug in u, and then we'll solve for x. It'll make more sense when we get to some examples. There's a lot of stuff like this in calculus. You take and manipulate a problem to your advantage to see it differently. Does everybody kind of see it, though? Let's do our first example. Mine are all coming off your worksheet. Here we go. So on your whiteboard, if you need it, or it's on the back. Number 9 on the back. Here we go. So it says, find the real or imaginary solutions. So you first see, okay, can I factor it? So look, there's no greatest common factor, and I'm looking at a degree 4, so we know there's going to be 4 solutions. And if you look at this, it's quadratic in form. So I say, okay, I'm going to let x squared equal u. So really, we know x to the 4th is x squared minus 5x squared plus 4 equals 0. We're replacing any x squared with a u. So we're not going to have x squared squared. We're going to have a u squared because x squared is a u. Minus 5 times x squared, which x squared is u, so 5u. Plus 4 equals 0. Now we say, okay, sweet, now I can solve it because it's just a quadratic. I like solving quadratics, and you should. If it can factor, factor it. What multiplies to b? Positive 4, a times c, and adds up to be b, which is negative 5. 1 times 4, correct? Yep. Negative 1 times negative 4 is positive 4, and negative 1 plus negative 4 is negative 5. Now I can quick factor this because my a value is a positive 1. So this factors to be u minus 1, u minus 4. The zero product property rule lets us set each of those equal to 0 and solve. So when we get u minus 1 equals 0, add 1, so u equals 1. Add 4, so we get u is equal to 4. That's u though, that's not our x. Weren't we solving for x? So we have to go back and say, okay, we knew that x squared equals u. So x squared equals 1. Now let's solve for x. What would we do to get x alone? Does everybody see where I replaced this? Put it back where our u substitution was. Hey, what do we do to get x alone, guys? Square root both sides of the equation. So we get x is equal to the square root of 1 is 1. Plus and minus 1, correct? Yeah. There's one of our solutions, actually 2 of our solutions. There's got to be 4. And we also have x squared is equal to 4. Solving for x, square root both sides of the equation. Root cancels out with power. X is also equal to plus and minus 2. Now, if you were to graph this on a graphing calculator, you would see it crosses the x-axis at positive 1, negative 1, positive 2, negative 2. Questions? Pretty cool, right? I know. This is literally one of my favorite lessons. I did the whole worksheet and I was just living the high life. Okay, another one? What? That's lunch? Are you guys? Let's do another one. Number 11. Okay, all my examples are coming off your worksheet. Here we go. So once again, you would say, is there a greatest common factor? That is always the first thing we do, because we don't want to use this method if that's the case. Nope. So then we say this is quadratic in form. So we're going to let x squared equal u. So we know that this is going to be u squared, right? X squared squared. Do I have to rewrite it out again, or does everybody understand? You got it? Minus 10 u's. X squared is u plus 16 equals 0. Now we say, okay, it is now quadratic. So we're going to solve by factoring if possible, if not quadratic formula. What multiplies to be 16 adds up to be negative 10. That's 8 times 2. Negative 8 times negative 2. Negative 8 plus negative 2. Right? So now we can quick factor this. This factors to be u minus 8 and u minus 2 equals 0. Set each of those, I'm going to say it 25 million times this year. The zero product property rule lets us split those up, set them each equal to 0. So we have u is equal to 8 and u is equal to positive 2. Is everybody okay with me skipping steps? Some people aren't. Because I set that equal to 0, then I added 8, set that equal to 0, added 2. So now we say those aren't our solutions, but we know x squared is equal to u. One of our u's was 8. And we also have x squared is equal to 2, because u is 2. Solve for x in each case. Square root both sides of the equation. Root cancels out with power. X is equal to plus and minus the square root of 8, which, if you remember, 2 times 2 times 2, right? 2 square roots of 2. Then over here, we'll square root both sides, square root both sides. So x is equal to plus and minus the square root of 2. So we have x is equal to positive 2 square roots of 2 and negative 2 square roots of 2. There's 2 solutions, which that's different than this solution, right? Square root of 2 is different than 2 times the square root of 2, so those are our other 2 solutions. Now, if they were the same solution, we would say x equals 2 square roots of 2 with a multiplicity of 2. Like if they came out exactly the same, right? That means it happened twice. Does everybody get what I'm saying? X equals negative 2 square roots of 2 with a multiplicity of 2. But they were different after. Because there are times when they come out the same. Okay, here we go. Let's do a 27. So we have 2x to the 4th minus 2x squared minus 28 equals 0. Once again, you always check, is there something in common that I can divide out or pull out first? 2. Let's factor out a 2. So we factor out a 2, left is x to the 4th minus 26 x squared, not minus 26. 26 divided by 2. Minus 13x squared and then minus 14 equals 0. We're going to ignore the 2 for a second, and we're going to make a u substitution. There's 3 terms, nothing more in common. It's quadratic in form. So we have u squared minus 13u minus 14 equals 0. We're going to solve the quadratic by factoring. You ignore the 2. For solving, we can ignore that 2 because it doesn't have a variable, right? Okay. So now we're doing what multiplies to be negative 14 and adds up to be negative 13. 1 times 14, correct? Negative 14, positive 1, correct? Yeah. 1 minus 14 is negative 13. So this quick factors, because my a value is positive 1, ignore the 2 for a minute. So this factors to be u plus 1 and u minus 14. The zero product property rule says we can set u plus 1 equal to 0. We can set u minus 14 equal to 0 and solve for u. Subtract 1, so u is equal to negative 1, correct? Add 14, so u is equal to 14. Now, the 2 didn't have a variable. If it did, one of our solutions would have been 2, like if it was 2x, it would have been 0, right? That didn't affect our solutions because it was just 2 times all that stuff. All right, so remember, these are the u solutions, but now we need to know what are our x solutions. So we made a u substitution. We said x squared equals u. You got to go back and plug that in. So we say, okay, if x squared equals, if x squared equals u, then x squared equals negative 1, because u is negative 1, and x squared also equals 14. Let's solve for x in each case. Square root both sides of the equation. So x is equal to plus or minus I, right? So this one had 2 imaginary solutions, so it's not going to cross the x-axis in those 2 places. And then square root both sides, square root both sides. X is equal to plus and minus the square root of 14, which does not simplify. So it's going to, this quadratic has 4 solutions, but it's only going to cross the x-axis in 2 places. The other 2 will be the floating up in, you know what I mean? Not ever crossing the x-axis. Well, we were solving, right? So if it said factor, we would need that in our final answer. Like this would have been the factored form. Set each factor equal to 0. So we don't need, this didn't have a variable. If it did, we would set that equal to 0. But see how there's not a variable? So we just can ignore it. Does that help a little? Good question. Technically, you could even say 2u plus 2 equals 0, right? And then solve for u, we get negative 1 still. Yes. True. Good point. Yep. Okay. Yeah. Good point. Any questions on that? Okay. Number 29, and then we'll let you practice these. Here we go. So it says, find the real or imaginary solutions. We have x to the fourth minus 81. A lot of people will make the sad and sorry mistake of just adding 81 and then fourth rooting it. That would not be correct. You'd get some of the solutions, but not all of them. So we would need to think about this differently. We'd say, actually, this is quadratic in form. So let x squared equal u. So won't we technically have x squared squared, right? So this becomes u squared minus 81 equals 0. So now we'll solve it by factoring what multiplies to be a times c, which is 1 times negative 81, and adds up to be b, which is 0. Won't that be 9 times 9? Negative 9 times positive 9. Negative 9 plus 9 is 0. We can quick factor it since our a value is 1. So u squared minus 81 becomes u minus 9 times u plus 9. So we get u equals positive 9 and u equals negative 9. Oh yeah, we could have done it that way too. Right? Square root both sides, plus or minus 9. Good point. That would probably been just as easy as factoring, right? Okay, so we get u is equal to 9, u is equal to negative 9, and then that's u though, so we have x squared is equal to 9, and we have x squared is equal to negative 9, solve for x, square root both sides, x is equal to plus and minus 3, square root both sides, x is equal to, the square root of negative 9 is plus and minus 3i. There better be 4 solutions since it was degree 4. Yep, 1, 2, 3, 4. So this would be another one that crossed at negative 3, positive 3, and then did not cross where the 3i solution and negative 3i solution. Questions? Pretty neat stuff. Okay, do these problems. Yeah, do these problems. Write it down somewhere so that I can go back for a second. Then we're going to come back and finish up learning the last part after lunch. So you have till lunch to do these ones. Moving on. Okay, so guys, we just learned how to take something that's quadratic in form and solve it. And we were able to see that it was quadratic and usually solved by factoring and then plugging those back in. Okay, so now here's how you will factor when you have the sum or difference of two perfect cubes. So we have something cubed plus something cubed. It's going to factor to be this form, always. A plus b times a squared minus ab plus b squared. I have a little song to help you remember that. So it goes like this. Are you ready? So the first thing is, what we do to get the front is we cube root this thing. So pay attention just so that you know how the song works. That will help you remember. So we cube root the front thing, and we'll call that the front. If we cube root a cubed, when we get a, that's the front. If we cube root b cubed, cube root it, we get b. That's what I'm going to call the back. So this song doesn't start till here, and it goes like this. The front with the front, then the front with the back, then the back with the back. I'm going to do it again. The front with the front, then the front with the back, then the back with the back. So if you notice, front with the front would be a times a, right? Yeah. Then the front with the back was a times b. Then the back with the back was b times b. So that's how that song goes, okay? Yes, everything with itself, okay? So then, the next thing is this is just a rule you have to memorize. This sign's always going to be the same as that sign, so I always put that in. Then this sign's always going to be the opposite of that sign, and then this sign's always positive. Okay, so looking here, if we have a cubed minus b cubed, it works the same. The front would be the cube root of a, the cube root of b would be b. So this would be the front, the back. So you would factor it. You put in a and b, the sign's the same, and your song goes the front with the front with the back, and the back with the back. Then you do, okay, this sign's the same as this sign's always opposite of that, and this sign's always positive. All right, here we go. Do you have that written down somewhere?
No.
Okay. Okay, here we go. Now you only use, this is only to factor, guys, so then once we factor it, we can set our factors equal to 0 and solve, because it's going to be quadratic, this piece, and this will be linear. Okay, here we go. So looking at number 1 on the worksheet, we have 8 cubed minus 27 is equal to 0. Notice it's the difference of two perfect cubes. Now the first thing I do is say, is there something in common I can pull out? 8 and 27, nothing in common. So we say, okay, 8x cubed, let's take the cube root of 8x cubed. No, I didn't write it like that. I didn't write it right. What's the cube root of 8, guys? The cube root of 8 is 2. What's the cube root of x cubed? X. So our front thing's going to be x. 2x times 2x times 2x is 8x cubed. Then cube root 27, and we get 3. So now this is just to factor it. This is not to solve it. So we know that solving, you have to set it equal to 0 and solve. So it's going to factor to be the front and the back. So we have 2x and then a 3. The sign is always the same. So you put a minus sign, right? Yeah. Then our song starts. This is the front. This is the back. Here we go. The front with the front. So the front times the front would be 4x squared, right? Yeah. Front with the front. Then the front with the back. 2x times 3. 6x. Then the back with the back. 3 times 3 is 9. Now we go through the process. This is a negative. This is always going to be opposite. So plus, this end sign is always plus. Do you see how we factored it? Okay, awesome. No, this is factored, right? These are the answers. The first part, you just have to put the front and the back, and then the sign will be the same as this sign. The front and the back. That doesn't go in the song. Yeah. Now, how do we solve? Well, it was equal to 0 here, so it's still equal to 0. Set each of those equal to 0 and solve. So we have 2x minus 3 is equal to 0. We'll add 3. So we have 2x is equal to 3, divide by 2. X is equal to 3 halves. There's one of our answers. Now looking at this piece, it's quadratic. You could try solving by factoring. However, most of these don't factor, so we're going to go ahead and do quadratic formula. So do you see why we spent a whole day doing the quadratic formula? So once again, there should be 3 solutions. So let's do the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4a. Do I need to write it down? Yeah. No, it goes like this. You put in this sign the same as this, and this sign's always opposite of that sign. This one's always positive. That's just the process we go through. So x equals negative 6. There's too much talking. Plus or minus. Are we like, what's going on? Plus or minus the square root of 6 squared minus 4 times a, which is 4, times c, which is 9. And that's all over 2 times a, 2 times 4. So we have x is equal to negative 6 plus or minus. Remember, when simplifying these, we only type that into our calculator. Go for it. Tell me what it is quickly. All over 8. What do we get? Well, we shouldn't always get different things. Type it in exactly as you see it with parentheses and everything. What problem did I say this was? You got negative 108? Negative 108, that's correct. So this is when we go off to the side and say, can I break down negative 108? Break it down into, I broke it down into 4 times 27. 4 breaks down into 2 times 2. 27 breaks down into 3 times 9. And 9 breaks down into 3 times 3. Don't double dip, meaning 27's not there, 4's not there, 9's not there. So we pull out a 3, we pull out a 2, we pull out an I. So 6, I square roots of 3. So we say, okay, we really have x is equal to negative 6 plus or minus 6i square roots of 3 all over 8. Now, then you would say, do all 3 things simplify by something in common? 2, right? This becomes a 4, this becomes a 3, and this becomes a 3. So our 3 solutions are x is equal to 3 halves and x is equal to negative 3 plus or minus 3i square roots of 3 all over 4. Now a lot of people, our original problem was 8x cubed minus 27 equals 0. They add 27, divide by 8, take the cube root. Do you see how you're missing a bunch of answers if you do that? Can't do that. You would only get that one solution if you did it that way. That's why we have to factor it. That's why we're talking about it, because a lot of people, if they see that on the ACT, get it wrong. Or they see it on my test, get it wrong. They would add, because they say, oh, I can just isolate the radical, add 27, divide by 8, cube root it, there's my solution. There should be 3 though, right? So there should be a red flag. Oh yeah, cube, sum and difference of 2 perfect cubes factor to be this. So yeah, until today you probably would have got it wrong. That would be one correct answer. Oh. Yes, you'll always get the one correct answer. Yeah, and then yeah. Okay, here we go. Let's do number 2. So we have the sum of 2 perfect cubes, cube root x cubed, and our front is x, correct? Yeah. Cube root 64, and we get 4. So this is our front, this is our back, so we factor it. We put in x and 4. There's too much talking, yo.
Wait, do you always do the...
Yes, to get your front and back, yes.
Wait, so when you, like,
sorry, the cube root of 64 is 4, and then the cube root of x cubed would be x.
oh.
So we're cube rooting the front thing and the back thing. Do we have other questions before we go on? Okay, so now we will go through our song. The front with the front, x times x is x squared. The front with the back is 4x. Don't put in the signs till last. The back with the back will be 4 times 4, which is 16. Now, our sign's the same here as it was up here, so it's a plus sign. This is opposite of that sign always. This is always plus. Now we say, okay, we factored it, period, yes. So now we're solving. So we said x plus 4 equal to 0. We said x squared minus 4x plus 16 equal to 0 and solve for x. So x is equal to -4. There's one of our solutions. This one solving using the quadratic formula because it doesn't factor. So we have x is equal to the opposite of b, which is +4, plus or minus the square root. We use parentheses. -4 squared minus 4 times a, which is 1, times c, which is +16. And that's all over 2 times 1. Okay, we're getting there. So we have x is equal to 4 plus or minus the square root. If you calculate that, you should get -48. All over 2. Then we go off to the side and say, okay, now I'm going to simplify. What's the square root of -48? 6 times 8, 2 times 3, 2 times 4, 2 times 2, right? Pull out a 2. Oh, another 2. And a negative makes it an I. 4i square roots of 3. So we have x is equal to 4 plus or minus 4i square roots of 3. This simplified to be 4i square roots of 3. And that's all over 2. All 3 things divide by 2. This becomes a 2, and a 1. Anything divided by 1 is just itself. So our 3 solutions are x is equal to -4, and x is equal to 2 plus or minus 2i square roots of 3. There's our 3 solutions. Okay? Do we need to do number 3? You sure?
Yeah.
Okay, yes. Number 3. Now notice, if we take, you right here, 2 is not a perfect cube, right? So what we would do is say, okay, let's see if there's something in common. On number 3, can't we factor out a 2? Doesn't 54 divide by 2? Yep. So we'll factor out a 2, and left is x cubed plus 27. Now we've got to factor it. Now we have the sum of 2 perfect cubes. So I take the cube root of the front, so the cube root of x cubed, which is x. The cube root of 27, which is 3. So we can factor this. We have a 2 in front. We're going to ignore that for this next part. We have an x and a +3, right? Then our song starts. The front with the front, which is x squared. The front with the back, which is 3x. The back with the back, which is 9. The sign's the same as up here. Opposite here, always positive here. Now we factored it. We set each of those equal to 0, but this 2 doesn't have a variable, right? So we can do this two ways. We can either distribute 2 in and then set this. We'd only distribute the 2 in right here, right?
Yeah.
But I'm just going to ignore it. We don't need it. So I'm going to set x plus 3 equal to 0. If there was a variable, we would set it equal to 0. But it's just 2, not 2x. So we have x plus 3 equals 0, x squared minus 3x plus 9 equals 0. So we'll have x is equal to negative 3. One of our solutions, solving with the quadratic formula, number 3. So we have x is equal to, whoa, is that a? What? Wait a minute. This is not number 3, is it? What problem is that? Oh, yeah. Okay. X is equal to, yeah, we're good. So we have 3 plus or minus the square root of 3 squared, or sorry, b squared, so it'll be negative 3 squared minus 4 times a times c, all over 2 times 1, which is 2. So we have x is equal to 3 plus or minus, underneath the square root, we get negative 27 all over 2. We go off to the side and we say, what's the square root of negative 27? 3 times 3 times 3, right, is 27. Pull out a 3, pull out an I, left is a 3. 3i, square roots of 3. So we have, sorry, ding, 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 ding. X is equal to 3 plus or minus 3i, square roots of 3, all over 2. All three things don't divide by something, so there's our two solutions, and there's our third solution.
What about the very top?
That didn't affect the solutions. That was a part of the factoring, right? Good question. So, yeah, good question. Well, in solving, it is gone, but not in fact. If I said factor, you would have to have that 2 there, right? But when we're solving, we didn't need it. If there would have been like a 2x, then we would have had also x equals 0. Are we all comfortable? Okay. So we don't need to do number 6.
I know.
Last one, and then I'll let you practice. Yeah, that's the last one that I'll let you practice. Okay, number 6, here we go. So, looking at this, 27x cubed plus 1, there's nothing in common, sweet. Oh, I noticed that it's the sum of 2 perfect cubes because what's the cube root of 27? 3. What's the cube root of x cubed? X, right? So there's our front thing. The cube root of 1 is 1. So this our front, this our back. So we have 3x. The sign stays the same, plus 1. Front with the front, which would be 3x times 3x, which would be 9x squared. The front and the back. 3x times 1 is 3x, and the back of the back is 1 times 1, which is 1. The sign's positive, so this one's the opposite, which would be negative. This one's always positive. Set each of those equal to 0 and solve. So we have 3x plus 1 equals 0. Do the math, guys. Minus 1, minus 1. 3x is equal to negative 1. Divide by 3. So x is equal to negative 1/3. There's one of our solutions. Quadratic formula. So we have x is equal to the opposite of b. So x is equal to 3 plus or minus the square root of b squared, which is negative 3 squared minus 4 times a times c, which is 1, all over 2 times 9. So we have x is equal to 3 plus or minus the square root. You type that in exactly as you see it, and you should get negative 27. Yep. Negative 27 all over 18. We just did that. We've just broken down the square root of negative 27. Didn't it become 3i square roots of 3? So we have x is equal to 3 plus or minus 3i square roots of 3 all over 18. All three things divide by 3. So this becomes a, don't say nothing, it becomes a 1, a 6, and a 1, right? So x is equal to 1 plus or minus 1i, which is just I, square roots of 3, all over 6. There's our 3 solutions. Okay. Do number 9 and then 17 through 22. This is what you're doing. Oh, sorry. Don't do. Sorry, I didn't even read my own handwriting. Do not do. Cross these out. 19, 17 through 22. You can put a cross through those. 9. So we didn't do number 9 on the front page. And then 17 through 22 we're not going to do. The rest you will do. So this is everything that we know how to factor and solve now. GCF, we haven't really solved GCF, we've just been factoring. Quadratics, factoring by grouping. Quadratic and form, and now sum and difference of two perfect cubes. Okay, ready, set, go. Check with me after you've done a few. Look back up here. When we did the front and back, we did not take the cube root of negative 27. We just took the cube root of 27, which is 3. The negative doesn't change your back. The negative just comes in when you're putting in your signs, right? Yeah. So you put in your negative here, so then this one's positive and this one's positive. So don't make that mistake. I've had a few people ask me, so I just wanted to make sure I was clear on that. You're welcome. Okay, look at this with me, guys. You have to be able to put it into like a story problem. So look at number 23 and read it with me. Guys, here we go. So 23 on your worksheet, it says, yikes, sorry, if I can get there. So number 23, it says, the volume of a container, and there will be a couple of these on your test. So it says, the volume of a container is 84 feet cubed. The width, length, and height are these dimensions, respectively. What are the container's dimensions? So we are actually solving, but we have to set up a true statement. So we know volume is length times width times height. So put in what we know. 84 is equal to x plus 1 times x plus minus 4 times x, right? Now we're going to solve by graphing calculator because otherwise it's going to be a lot harder. So graph it in your graphing calculator. You go y equals. In y1, I put in the top function, the one of the functions, it doesn't matter. And then in y2, I put in 84. Now think about it, guys. There's a straight line at 84. So don't I need to see as high up as 84 on my y-axis? So I go to window, and I change my y max to 90 so I can see above 84. Does everybody understand that? Yeah. So then I hit graph, and if you need to change your x max to see further this way, then you can further on the x positive. So I hit graph. Now I want to know where are these functions equal, so I do second trace, go to intersect, hit enter. It says first curve, it's on the cubic. I hit enter. It says second curve, I'm on the line. Hit enter. You just can hit enter twice. Enter again. X equals 6 is where they intersect. And x is equal to 6. So let's answer this correctly. Just think about it. Your y max has to be above 84 so you can see as high up as 84, right? If you can't see it far enough on the x-axis this way, if you need to see further this way, you would change your x max to greater. I think mine was like at 20 or 10. So we solved for x equals 6. So that's true. Our width was 6, our length was 7, and our height was 2. Does everybody see the dimensions of the box? So let's read the next one, number 24. It says, the product of consecutive integers, now consecutive means one right after another. This is an ACT problem. The product of, and this one is 3 consecutive integers. I have seen on the ACT the product of 2 consecutive integers. Look and see why these are consecutive. That means like 1, 2, and 3 are consecutive. They come one right after another. So if we have n, isn't 1 less than that n minus 1? 1 greater than that n plus 1. Okay, so it says the product, which means multiplication. So we have n minus 1 times n plus 1 times n. The product is equal to negative 336. I set up a true statement. Now I'm going to solve. It's cubic, and I want to know when does this function equal this function. So once again, I'm going to solve by graphing. Graph it in your graphing calculator. You can use x's instead of n's. But now think about it. Don't we need to see as far down as negative 336 at least? So I've made my window like negative 400 on the y. Go to window, Y max, Y min, I mean. And I just typed it into my calculator. So I want to know where they intersect. Do I need to show you, or are we good? So on the ACT, while those of you are calculating it, kind of multitask. If it's the product of two consecutive integers, and they didn't give you the consecutive integers, you would just, the product of two consecutive integers is like 50, let's say, or something. You would just set up your own statement. N times n plus 1, there's two consecutive integers is equal to 50. Do you see how that works? Then solve for n by graphing. That was just another example. Okay, where do we get the intersection at? X equals n equals -7. So answer it correctly. It says, what are the integers? So we have -7. What's one less than that? -8. What's one greater than that? -6. Now you can check your answer. Is -8 times -7 times -6 -336? Yup. Ding, 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 ding. On the ACT, I've seen them say, what is the largest integer? So wouldn't we say -6 is the largest, if that was the case? Do you see how you have to think about the wording? Okay. Yeah, but this one didn't. It said, what are the consecutive integers we set up?
Wait, did we?
Questions? Okay, finish the worksheet.